Myself, Madhuri Modak, Assistant Professor in Mathematics, Department of Computer Science, Abhinay Senior College. Discrete mathematics is very important for students of computer science. Now here we start with unit number 3, Techniques of Counting of Discrete Mathematics. Now the next point in unit number 3 is permutations and combinations. Now first see what is the definition of permutation. A permutation of a set of distinct objects is an ordered arrangement of these objects. Now what is R permutation? An R permutation of n distinct objects is an arrangement using R of the n objects. Now see, there are n distinct objects, means none of them are identical, all n objects are different objects. Now out of that n distinct objects, if we are taking arrangements of only r at a time, then that arrangement is considered as r permutation of n distinct objects. Now see, what is actually r permutation by one example. Suppose there are three letters, say a, b, c, and by taking two at a time we are doing the arrangements. So how many arrangements are possible and what are that arrangements? Now as there are A, B, C three letters and we are taking only two at a time, one arrangement is by taking A and B. So the arrangements are A, B, B, A. Now similarly, instead of taking A and B, we can take A and C. So AC and CA, and then we can take B and C. So the arrangements are BC and CB. So in this way, how many arrangements are there? By taking two at a time out of ABC. So AB, BA, BC, CB, AC, CA. So these six arrangements are possible. So this example is nothing but two permutation of three distinct objects. But every time it is not possible to find all such permutations and then count that number. So there is one formula which we can use directly. Number of R permutations of a set with n elements is denoted by PNR or NPR. Now see how to find that answer. So for that we are using this theorem. If n is a positive integer with 1 less than or equal to r less than or equal to n, then PNR is equal to n into n minus 1 and so on, n minus r plus 1. So this formula actually comes by product rule because we are arranging only r elements at a time out of n elements. So it is nothing but arrangement at r places by taking n different objects. So first place can be filled in any of that n objects. Now since repetition is not allowed in this case, second place can be filled in n minus 1 ways because we cannot use the first object which we have used for first place. Third place can be filled by remaining n minus 2 objects and so on. And in this way, rth place can be filled by n minus in bracket r minus 1 ways, that is n minus r plus 1. Now as we are filling all the r places at a time by product rule, the formula is PNR is n into n minus 1 into n minus r plus 1. So remember this formula. Now this is same as n factorial upon n minus r bracket factorial. Now instead of taking r at a time, if we are doing arrangement of all n objects at a time, then PNN is equal to n factorial. For example, suppose there are three letters A, B, C and we are taking all three at a time. Then as number of objects are 3, it is nothing but P33. So P33, that number gives total number of arrangements of that 3 objects, which is 3 factorial equal to 6. See, there are ABC, then the arrangements are ABC, ACB, BCA, BAC, CB and CAB. So these 6 arrangements are possible. So this is the formula to find the number of arrangements of R n objects taken R at a time. So the formula is PNR is equal to n factorial upon n minus R factorial. And I think you know what is factorial. If not, see, I will tell you what is n factorial. Now for any natural number n factorial is defined as the product of natural numbers from 1 to n or n to 1. That means 1 into 2 into 3 up to n. And remember, 0 factorial is always 1. Now these are the important formulae for NPR or PNR. Now the condition on R is 1 less than or equal to R less than or equal to N, because N different objects are there. So for arrangement we can take at a time 1 or maximum N objects. So it is 1 less than or equal to R less than or equal to N. Now see first example. Find the permutation of the set A is ABCD taking two elements at a time. Now here A contains 4 elements, that means N is equal to 4, and we are taking 2 elements at a time, so R is equal to 2. So this is nothing but the 2 permutations of 4 element set. So by formula it is P42 is equal to 4 factorial upon 4 minus 2 bracket factorial. So it is 4 factorial upon 2 factorial. Now 4 factorial is actually 4 into 3 into 2 into 1. And this is 2 into 1, so we can cancel 2 into 1. So it is simply 4 into 3, that is 12. Now second example, how many permutations of the letters A, B, C, D, E, F, G, H contain the string A, B, C? Now here we are doing actually permutation of all the letters which are 8 in number. But the condition is that while arranging these 8 letters at a time, every arrangement contain the string A, B, C. That means A, B, C should come in the same order. And so here we consider A, B, C as one block and the individual letters D, E, F, G, H as the remaining letters. So how many letters are remaining? 5 letters are remaining. And as A, B, C should in the same order, we consider it as one block, one letters. So remaining 5 letters and this is one letter. So actually we are arranging 6 letters at a time. So arrangement of 6 letters taken 6 at a time is nothing but 6p6, which is 6 factorial. And hence the answer is 6 into 5 into 4 into 3 into 2 into 1, which is 720. Now one more example. How many ways are there to select a first prize winner, a second prize winner, and a third prize winner from 100 different people who have entered a contest? Now here it matters which person wins which prize. The number of ways to pick the 3 prize winners is the number of ordered selections of 3 elements from a set of 100 elements. That is, number of 3 permutations of a set of 100 elements. See why? Now for first prize, there are 100 persons who can win it. Now, after winning the first prize by one person, second prize has 99 persons available. Now after getting the second prize, there are 98 persons for third prize. So it is nothing but a arrangement of that 3 prizes where total 100 persons are available. So it is 100p3. By formula it is 100 factorial upon 100 minus 3 bracket factorial, which is 100 factorial upon 97 factorial. Now as 100 factorial is bigger than 97 factorial, we express 100 factorial in terms of 97 factorial as 100 into 99 into 98 into 97 factorial upon 97 factorial. So we can cancel 97 factorial. So the answer is 9,70,200. Now, next is permutation with repetition. Now, the number of R permutations of a set of n objects with repetition is n raised to R. So, this is nothing but there are total n objects available and we have to do the arrangements at R places only. But repetition of object is allowed. At that time, each place can be filled in n ways and there are R places available. So by product rule, number of permutations is equal to n into n into n R times, which is n raised to R. Now there is one more theorem, permutation with indistinguishable objects means identical objects. Now see the statement of theorem 4. If there are n1 indistinguishable objects of type 1, n2 indistinguishable objects of type 2 and so on, nk indistinguishable objects of type k, then n1 plus n2 plus nk is equal to n. Then the number of permutations of these n objects is n factorial upon n1 factorial into n2 factorial into nk factorial. See, there are k types of objects available. Of type 1 n1 identical objects, indistinguishable objects. Of type 2 n2 indistinguishable means identical objects, means all are same. And in this way of kth type there are nk indistinguishable or identical objects. Now total of all these objects is equal to n. Now if we are doing arrangements of all these objects divided into k types, then total number of arrangements, permutations is equal to n factorial upon n1 factorial into n2 factorial into nk factorial. Now first example, find the number of binary sequences of length 5. Now see, forming a binary sequence of length 5 is an arrangement of 0 and 1 on 5 places. Now only 5 places are there and we are using only 2 digits 0 and 1. It means repetition is must. So here this is a permutation in which repetition is allowed. Now there are 5 places, means it is a 5 permutation, and on each place we can write either 0 or 1. It means each place can be filled in 2 ways, either by 0 or 1, and hence the required answer is 2 into 2 into 2 into 2 into 2 5 times, that is 2 raised to 5 equal to 32. So this is an example of permutation with repetition. Now see second example. Find the number of arrangements that can be made out of the letters of the word accountant. Now here in the word accountant, we have to do all possible arrangements using all the letters. So we want that number of arrangements. Now whenever some word is given for arrangement of letters, at that time first check whether the letters are distinct or some of them are repeated identical. Now here in the word accountant, total 10 letters are there. Now if these 10 letters were distinct, then in that case total number of arrangements are easy. It can be done in 10p10, that is 10 factorial ways. But it depends on whether the letters are repeated or distinct. Now in case of accountant, letters are not distinct. So count each type of letter, how many times it is appearing. Now here A is appearing 2 times, C 2 times, O1, U1, N 2 times, and 2 times. So in this way, actually there are 6 different letters. So these 6 different letters we can consider as 6 types of letters, where of first type is A, which is appearing 2 times. So this is one type in which these objects are identical. This is second type, these are identical. So in this way, total 10 letters are divided into 6 types, and all the letters of that type are identical. So while doing the arrangements, we have to use theorem number 4. So required answer is n factorial upon n1 factorial into n2 factorial and so on into nk factorial is 10 factorial upon 2 factorial into 2 factorial into 1 factorial into 1 factorial into 2 factorial into 2 factorial. So solving this, we get the answer as 2,26,800.